today's video, I'm going to take a look at the definite integral of 5x from 0 to 1, 5x square root of x squared plus 3 dx. So in this scenario, it's first thing that would jump out to you is looking at using substitution, because you have that term inside the square root, but that's not always going to work out. Because what we want to have happen is we want to use substitution. We want to set u equal to that term inside, and then we take the derivative of that and hope that it helps us out with this 5x term. So if you have seen integration by parts before, you might kind of get in this like weird zone of like, do I use integration by parts? Do I not use integration by parts? But when you're using substitution, if you can set your u and then that derivative takes care of the other terms, then you're good. And if it doesn't work out like that, then you need to go a little bit further and try out integration by parts. So let's just try this out. Let's set u equal to x squared plus 3, so that term on the inside. Take the derivative. So the derivative of x squared plus 3 is 2x dx. So now notice, we have 5x and we get 2x. That's okay. 5 is just a constant. So if it even helps you out, take out that 5, because here we could show you here. So it's from 0 to 1. That's x square root x squared plus 3 dx. So if that 5 is just a constant, 2 is also just a constant. So if you think of it like that, then like, oh, okay, I'm good. X dx, x dx. That's fine. That's completely fine. And some people like to just show like this is divided by 2. So x dx is equal to du over 2. So what you do is you replace x dx with du over 2. So what we just end up with is 5/2, because that du over 2, 1/2 is a constant, take that out. So 5/2 from 0 to 1. And I replaced x squared plus 3 with u. So that's going to be u to the 1/2 du. And then that's our substitution. So then we're good to move on from there. And again, if that doesn't work out, if we get something weird where this x isn't completely substituting out, then we need to use integration by parts would probably be our next step. Or maybe just try a different substitution, or maybe you're missing something, but integration by parts would be the next step there. So now let's perform this integration. Nothing too fancy. I'm going to add 1. So this is over 2. So this is going to be u to the 3/2 over 3/2 times that 5/2. And I'm going to go this way. Kind of mad that I went down that way. So two things that could happen here. This is, so the u to the 3/2 divided by 3/2 is the same thing as 2/3. And then I'll write it here because I don't want to skip too many steps. So we have 5/2 times 2/3 u to the 3/2 from 0 to 1. And then the 2's are going to cancel. So we're left with 5/3 u to the 3/2 0 to 1. Okay. So now the next step, you could do, so sometimes people will actually change the limits of integration, meaning you'd plug in 0 and 1 into the integral. Some textbooks do that, some textbooks don't. That's really important, though. I'm not saying that you don't have to do that necessarily. It's really important that you know how to do that if you plan on moving in a little bit more advanced calculus, like Calc 2, like going past these types of steps. But for this video that I'm making right now, like this is geared towards more the business calculus student, where most business calculus textbooks will just leave it as 0 to 1. But some textbooks, like if you're trying to self-study and you're seeing this video, some textbooks will change these limits of integration in terms of u. All right, so I'm just going to go with 1. Now, what I am going to do, though, before I start just evaluating, is you want to make sure you're taking back your u. So if you're not changing the limits of integration, you want to change out u for the x squared plus 3. So I'm going to have 5/3. I'm changing u, x squared plus 3 to the 3/2 from 0 to 1. And what I mean by changing the limits of integration is if I wanted to keep it in terms of u, I could change around those limits of integration and just plug into that, but changing what those values would be. But I'm going to change the u back to x squared plus 3. So then now we're all good to go from 0 to 1. No questions asked there. Now let's plug in 1. So we're going to have 5/3, 1 squared plus 3 raised to the 3/2 minus 5/3, 0 squared plus 3 raised to the 3/2. And then I think we should be good with that. Okay, yeah, so it checks out. 4.67 would be our answer. So the difficulty with this one is just making sure you're evaluating this portion correctly. Like just doing this portion correctly. And right here again, I have u to the 3/2 from 0 to 1. This 0 to 1 is in terms of x. So I have to replace u with what my u is equal to, x squared plus 3, and then evaluate. Changing your limits of integration in terms of u, these numbers would then change. But I left it as is, changed u back to x squared plus 3, and then evaluated. And then I get that whole statement. Be careful with your calculator, and you should get 4.67. So hopefully you're able to get that answer.